So the topic of our today's class is matrices. Okay, this topic is from Mathematics Syllabus 4024. Learning objectives of this topic given in CI syllabus are: display information in the form of a matrix of any order, solve problems involving the calculation of the sum and product where appropriate of two matrices and interpret the results, calculate the product of a matrix and a scalar quantity, use the algebra of 2 by 2 matrices including the zero and identity 2 by 2 matrices. Then the last learning objective is calculate the determinant A and the inverse A inverse of a non-singular matrix A. So here we have a matrices. So basically a matrix is an array of numbers. If we arrange numbers in a particular order in any square bracket, then we will call this matrix. Okay. In a matrix we have rows and column. Okay. So what are rows and column? Rows are like go from left to right. If we move from left to right, these are rows. If we move from left to right, these are rows. Okay, so basically here we have two rows. Okay, and if we talk about columns, so column are from up to down. So these are column 1, column 2 and column 3. Okay, when we write the order of a matrix, we will write order in a way like row multiplied by column. So if we write the order of this matrix, here we have 2 rows and 3 columns. So the order of this matrix is 2 by 3. Okay, so this matrix has 2 rows and 1 column. So first of all, we have discussed that the horizontal ones are rows, okay, and the vertical ones are column. Okay, up to down columns and left to right rows. Now, if we have to add 2 matrices, okay, we can add 2 matrices only when their order is same. So if we check the order of the first matrix, here we have 2 rows and 2 columns. So this one is 2 by 2 matrix, as well as this second one is also has 2 rows and 2 columns. So this matrix is also 2 by 2 matrix. So addition is possible only when we have same order matrices. Okay. Now how we will add it? First term will be added into first term. Okay, the second element will be added into second element, third element will be added into third element, and then fourth element will be added into fourth element. This is how we will do addition. So 3 plus 4 is equal to 7. Similarly, 8 plus 0 is equal to 8. Then 4 plus 1 is equal to 5. And then 6 minus 9 is equal to minus 3. This is how we will do addition. So for addition, the order of both matrices must be same. For example, if we have a matrix, the first one same matrix 3, 8, 4, 6, and then we have another matrix like 2 minus 1. So we cannot add these 2 matrices because the first matrix has order 2 by 2 and the second matrix has order 2 by 1. So in this case, we cannot add these 2 matrices. So for addition, the order of the matrix should be same. Now, for subtraction also, the same condition which we have for addition, we have the same condition for subtraction also. Like the order of both matrices should be same, only then we can subtract 2 matrices. Okay. So the order of this first matrix is 2 by 2 and this matrix is also 2 by 2. Okay. Now, how we will subtract this? 3 minus 4 is equal to minus 1. Then 8 minus 0 is equal to 8, then 4 minus 1 is equal to 3, and then 6 minus minus will be plus 9 because here we have 6, then in between we have negative sign. So 6 minus sign, and then inside the bracket we will write this minus 9. So minus minus will be plus. So 6 plus 9 is equal to 15. Okay, so here we have 15. 6 plus 9 is equal to 15. Okay, again I am repeating that for addition and subtraction, the order of both matrices should be same. Now multiply by a constant. So if we multiply any matrix by a constant number or by any scalar number, any whole number, so it will multiply with each element of a matrix. Like here we have 2 by 2 matrix. So if we multiply this matrix by this 2, this is scalar number 2. So 2 will be multiplied with each element. So 2 multiplied by 4 is 8, then 2 multiplied by 0 is 0, 2 multiplied by 1 is 2, and 2 multiplied by minus 9 is minus 18. Okay, so this is a scalar multiplication. So if we multiply any matrix by a scalar number, any constant number, 2 or minus 1 or plus 3 or plus 9, any number, then it will multiply with each element of a matrix. Now next we have multiplying a matrix by another matrix. So if we multiply two matrices and as in addition and subtraction, the order of the matrix must be same. In multiplication, this is not the case. In multiplication, the column of the first matrix must be equal to the rows of the second matrix. Column of the first matrix must be equal to the rows of the second matrix. So if we write the order of these two matrices, here we have 2 rows and 3 columns, and the order of the second matrix is 3 rows and 2 columns. Okay, so as I have told that the column of the first matrix must be equal to the rows of the second matrix. If these two are equal, then only the multiplication is possible. Otherwise, multiplication is not possible. Okay, now how we will multiply this? Remember this formula for the multiplication: first row, first column, first row, second column, second row, first column, second row, second column. If we have more rows, we will add it accordingly. If we have more columns, we will add it accordingly. And if we have more rows, we will add it accordingly like this. Okay. Now, if we mark rows and columns here, okay, so here we have row 1 and this is row 2. Okay, this is column 1, okay, and this is column 2. So if we multiply this, the first one is first row and first column. So first row, first column. So first element will be multiplied with the first element. So 1 multiplied by 7. Then when we multiply the second number, we will write positive sign in between. Then 2 multiplied by 9. 2 multiplied by 9. Then again plus sign. And then we will multiply 3 by 1. So here we have multiplied first row, first column. Now we will multiply first row with second column. This one. First row and second column. So if we multiply first row and second column, the first number we have 1. So 1 multiplied by 8. Okay. So with some little space, we will write 1 multiplied by 8. Then plus sign. Then 2 multiplied by 10. So 2 multiplied by 10. Then plus sign. 3 multiplied by 12. 3 multiplied by 12. So we have multiplied first row, first column and first row, second column. Now we will come into second row. In second row, we have second row and first column. So here we will multiply second row and first column. So second row, first element, multiply with the first element here. So it's 4 multiplied by 7. Then plus sign. 5 multiplied by 9. 5 multiplied by 9, again plus sign, 6 multiplied by 11. Okay, now the last one is second row, second column. Second row, second column. So in this case, we will multiply 4 by 8, 4 by 8, plus sign, 5 by 10, and then plus sign, 6 by 12. Okay, so we have multiplied first row with first column, then first row with second column. So erase this one so it will be more clear. Now what we have done, we have multiplied first row first column, first row second column, second row first column, and second row second column. So here we have first row multiplied by first column. Okay, this is how we will multiply. First element with first element, second element with second element, third element with third element, and in between we will write positive sign. Then first row and second column, then second row first column, and then second row second column. This is how we will do multiplication. Now we will simplify this and we'll get the answer. So if we multiply this, it's 1 times 7 is 7, plus 2 9 times 18, 3 1 times 3, 8 1 times 8, 2 10 times 20, and it's 36. Then here we have 28 plus 45 plus 11, 66, and then here we have 32 plus 50 and plus 72. Okay, now we will add 18, 7 and 3. Similarly, we will add 8, 20 and 36. Then we will add okay, here we were having 11, so it's 33. Okay, so then we will add 28, 45 and 66. Then we will add 32, 50 and 72. When we add these numbers, we will get these 4 answers here. Okay, now remember one more thing. As I have told that the column of the first matrix must be equal to the rows of the second matrix. So here, if this matrix order is 2 by 3 and this matrix order is 3 by 2, then these two must be equal. And if these two are equal, then the multiplication is possible. So we have multiplied this. Now when you get the answer, the order of the answer will be this one. Okay, this will be the order of the answer. So if you check this matrix, this is 2 by 2 matrix. Okay, so the column of the first matrix must be equal to the rows of the second matrix. Only then the multiplication is possible. Now next we have determinant of a matrix. So determinant is basically when we find the determinant, we will get the determinant of only non-singular matrix. If matrix is singular, then the determinant will be 0. Okay, and if we have 0 determinant, then the inverse is not possible. We will discuss this later on the next slide. So here we will find the determinant. For determinant, what we will do, we will multiply diagonals, and in between we will write negative sign. So first we will multiply the first diagonal, so it's 3 multiplied by 6. Then in between we will write minus sign, and then 8 multiplied by 4. So we will multiply both diagonals, first diagonal, then second diagonal, and in between we will write negative sign. So 3 times 6 is 18 and 8 times 4 is 32. When we subtract this, our answer is minus 14. So basically this is non-singular matrix. If we simplify this and our answer is 0, then that matrix will be a singular matrix. Okay. Then after determinant, we will find inverse. So the formula of inverse of a matrix is A inverse. For example, if we have a matrix A, so A inverse will be equal to adjoint of A divided by determinant of A. Okay. So we have already discussed the determinant and we were getting minus 14. Okay. In last part. Okay. Now here first we will find the adjoint of A, and then we will find the determinant, and then we will divide it. So for example, we have a matrix A, B, C, D. So the determinant will be first matrix, first diagonal multiplied by minus sign, second diagonal. Okay. So first we will multiply the first diagonal, so A multiplied by D. Then in between we will write negative sign. Then multiply the second diagonal, so it's BC. So here also they have written determinant of this matrix in the denominator. Then for adjoint of A, okay, for adjoint of A, remember we will change the places of the first diagonal, this one. So if we change the places, it will be D will be here and A will be here. Okay, so we have changed its places. Now D is here and A is here. And the sign of the second diagonal. So if both are having positive sign, then both will be negative. Okay, I am repeating, for determinant we will change the places of the first diagonal and sign of the second diagonal. Okay, so here we have this one as adjoint. Okay, and here we have determinant. Now we will divide each value by this determinant, so we will get the inverse. Now, for example, we have a question here. We have to find a matrix 4, 7, 2, 6. Okay, so if we find the determinant, we will multiply diagonal. So 4 times 6 is 24, and then minus sign. 7 times 2 is 14. Okay, so 2 6 times 24 minus 7 2 times 14. So 24 minus 14 is 10. And then we will find the adjoint. So in adjoint, we will change the places of this first diagonal. So it will be 6, 4, and the sign of this second diagonal. Okay, so here both are positive, so it will be negative 7 and negative 2. Okay, as we have discussed that in inverse, determinant is in the denominator. So that's why we are writing 1 upon 10 in the denominator. 10 basically is the determinant, and we are writing this in denominator. So it's 1 upon 10 bracket 6 minus 7 minus 2, 4. Now here we have got the answer. If you write this answer, examiner will give you full marks for this. Okay, so it doesn't need to divide it separately with each number and then write the final answer. Okay, so if you leave answer here, you will get full marks. Now here we have very important property of A and A inverse, like any matrix and its inverse. So if we multiply a matrix by its inverse, okay, or either inverse of a matrix by its matrix, okay, then in both conditions the answer is an identity matrix. What is an identity matrix? Identity matrix is 1 0 0 1. This is an identity matrix. Okay, so if we multiply A by its inverse or either A inverse by its matrix, in both cases the answer is identity matrix. Okay, if you check the past paper questions, in some of the questions they have given A multiplied by A inverse, and then they have mentioned one of the matrix with this like 0 and minus 2. So if we multiply A into A inverse, it's equal to an identity matrix 1 0 0 1. So if we multiply this by a given matrix 0 minus 2, then remember that if we multiply any matrix by identity matrix, the answer will be same matrix. So our answer will be 0 minus 2. Okay, so if any of the question of the past papers you get this part like A multiplied by A inverse and any matrix will be given with this, then the answer will be same matrix, because A multiplied by A inverse is an identity matrix. Okay, or either A inverse multiplied by A is an identity matrix. Then here one more most important thing I must share with you. Like for example, we have M A is equal to B. All these are matrix. Okay, now they are saying find the value of matrix M. So when we shift A on the right hand side, then remember that when we shift A on the right hand side, it will be inverse of a matrix. Okay, so when we shift it, it will be inverse of matrix A. Then here the most important thing is its placement. Like on the left hand side, if A is on second position, then when we shift it on the right hand side, it should be on the second position. Okay, or for example, we have AM is equal to B. So in this case, if we shift A on the right hand side, then it will be A inverse, but it will be on the first position, because on the left hand side it was on the first position. So when we shift it on the right hand side, it will be on same first position. If you change the position of this inverse of a matrix, then your answer will wrong. Okay, so the placement is very important when you are shifting any matrix. If its position is second, so when you shift it on the right hand side, it will be on second position. If its position is first on the left hand side, so when you shift it on the right hand side, it will be on the first position. Okay, now the last thing that is very important is singular matrix or non-singular matrix. So if a matrix has determinant and in terms of any number, like +2, -2, or -1, +1, +9, +10, +20, okay, or -20, -1. In all these cases, when we get the determinant, then inverse is possible, in which case the inverse may not exist when the determinant is 0. So for example, here we have this matrix. So 3 multiplied by 8 is 24, then minus sign in between, and 4 multiplied by 6 is 24. So if we check, these two will get cancelled, so it's 1/0. So in this case, the determinant or the inverse is not possible, because when we divide each number by 0, okay, then all these numbers will be undefined, because whenever we divide any number or variable by 0, then it will be undefined. Okay, so if we are getting determinant 0, then that inverse will not exist, and that the inverse will be, because the inverse will be undefined. Okay, so that's why if you get any matrix in which they are asking to find the inverse, and when you find the determinant and your determinant is 0, so it means there will be no inverse. Okay, but you must check your answer of determinant once again. If you are getting 0, that have I done it correctly, or maybe I have done some mistake in that solution. So do remember to check it once. Okay, then one thing more, maybe in the past paper question they will give the matrix, and they will say in the question that it's because it's a singular matrix, find the value of k. For example, we have a matrix 0, k, 2, 3, and they are saying that it's a singular matrix, find the value of k. So remember, when the matrix is singular, then its determinant is 0. So here we will find the determinant. So 0 multiplied by 3 minus 2 multiplied by k, and then we will keep it equal to 0, because we know that the in the question they are saying it's a singular matrix, so its determinant will be 0. Then it will be 0 minus 2k is equal to 0. So minus 2k is equal to 0, and k is equal to 0 upon minus 2. So the value of k is also 0. Okay, so in which case the inverse is not possible when we get 0 as a determinant. Okay, and if in the question they are saying that it's a singular matrix, so find the value of k or any unknown which is given in the matrix, then in that case you will find the determinant and keep it equal to 0. Okay, I hope you have understood this topic. Thank you.